Hey guys, before you start your quick little formative, I wanted you to review one more type of problem, just to make sure that you have it. And specifically, I wanted to give all you non-sports people a more concrete and real-world example that you may interact with on a daily basis. So we want to know if more females are using Twitter regularly than males. So a recent random sample of 200 US females, so that's the total amount of females that we sampled, that's from our sample, and we're talking about females, revealed 110 women use Twitter regularly. So the amount of girls or females that use Twitter is 110 out of 200. And the amount of boys, so males, revealed that out of a sample of 150, that only 60 use Twitter regularly. So that's males. Again, this is from a sample. So whether you agree or disagree with it, it's just a sample. So males is 60 out of 150. Okay? And we want to construct a 95% confidence interval for the true difference in proportion for who uses Twitter regularly. And I think that women are using it more. So I always kind of determine my P of A, my P of B based on what I think is going to happen because that means I concretely understand it a little bit more. So I think that women use it more. So I think my interval is going to be entirely positive. So P hat of A is going to be females and P hat of B is going to be males. So the proportion of 110 out of 200, that's my P hat of A. So 110 is technically my number of successes and 200 is my number of attempts. Okay, so that means P hat of A means from my sample, 0.55 females use Twitter regularly, or 55% of the females use Twitter. And my number of attempts for females was 200. For males, I have 60 out of 150, which is 0.4. So 40% of males are using Twitter regularly. And the number of attempts for males, or the number of samples, or the sample size for males is 150. Okay, and so that means we've got two different proportions. So there's four total numbers, and I've got two proportions. 110 out of 200 for females, and 60 out of 150 for males. So that's how you know you're going to use proportions versus means versus single proportions, is it's going to say that of this or out of this, out of or of something, that's going to represent a proportion. It's going to be important to know the difference between what a proportion looks like versus what a mean looks like. Okay, and my formula again is P hat of A minus P hat of B plus or minus 2 times the square root of P hat of A 1 minus P hat of A over N of A plus P hat of B 1 minus P hat of B, all under that square root, over N of B. So an ugly formula, but we know how to use it. So I've got P hat of A, I've got P hat of B, I've got N of A and N of B. So I think it's really, really helpful to kind of start off by doing this little section because then you know everything that you're plugging into your formula. Okay, so P hat of A is the female proportion, so that is 0.55 minus 0.40 plus or minus 2 times the square root of 0.55, 1 minus 0.55 over 200 plus 0.40, 1 minus 0.40 over 150. And notice it really doesn't matter the order that you do the P hat of A. Everything under the square root is added together. So if you accidentally put 0.40 in the first spot, no matter what, you're adding it together, so it's the same thing. It only really matters when you're doing the single value estimate. So again, this first part before the plus or minus, that's your single value estimate. The second part after, the whole thing including the 2, is your margin of error. Okay, so 0.55 minus 0.40 is 0.15 plus or minus 2 times the square root of all this. So anytime I do this, I first start by finding everything inside the square root and then I take the square root. So 0.55, 1 minus 0.55. And then the last thing would be taking the square root, and I got 0.053. I really suggest that you check that to make sure that you are getting the same value so that you can plug it in the calculator. Again, if you're still struggling and don't have any resources to help you find that value or to use, make sure you contact your teacher to find what website or what application can be used as a calculator. Okay, so multiplying by 2, I get 0.15 plus or minus 0.106. So this here is my single value estimate. This is my margin of error. Single value estimate is my best guess at what I think the true difference in proportion is. It is not the true proportion, it's just what I think it is. So I think that females use Twitter 15% more than males use Twitter, and that with 95% confidence, I'm within 10.6% of that value. So if I take 0.15 and I minus 0.106, that gives me 0.044. If I take 0.15 and I add 0.106, that'll give me 0.256. Okay, so my interval is 0.044 to 0.256. So hopefully by this time you know how to interpret it. We are 95% confident that the interval of plausible values from 0.044 to 0.256 contains the true difference in proportion of individuals who use Twitter, okay, between males and females. So after that, I want to talk about what this number actually reveals. So because the interval is entirely positive, so the interval is entirely positive, that means that within that 95% confidence interval, in every single instance, females were using Twitter more than males. So we have, because the interval is entirely positive, we have evidence that females, does that say females? Hopefully. Use Twitter more than males. Now here's something that's kind of interesting. If I were to use males as my p hat of A, so if p hat of A was 0.40 and p hat of B was 0.55, the single value estimate then would have been negative. And further, I probably, let's say my margin of error wouldn't have changed because that addition underneath. So I'm going to do negative 0.15 minus 0.106 and negative 0.115 plus 0.106. And I'm actually going to go grab a calculator real quick, so stay tuned. Okay, so negative 0.15 minus 0.106, that gives me negative 0.256. And if I do negative 0.115 plus 0.106, and that gives me negative 0.044. I don't know why I needed a calculator for that. I probably could have figured that out. Okay, so in this instance, the interval is entirely negative. And it's negative because I chose my first proportion to be males. So that means that we have evidence still that females use Twitter more than males because my interval is entirely negative. Meaning in every instance, females were using Twitter more than males, making that negative confidence interval. So hopefully you can kind of see the resemblance between the two. The conclusion should be the same, but it's how you understand it that makes p hat of A and p hat of B make more sense. So hopefully this little review helps you and you're ready for your short little formative. Hope you guys all are having a good week.